The thing that's unique about my job is that I get to discover things that were not known before. Like literally, I might be the first person in the world on the planet to learn this new thing. And it's amazing. I mean, I think biology, molecular biology it's beautiful and it's amazing when you finally figure something out. Like the science always tells the truth. It's just whether you're clever enough to hear and see what it's telling you. And so I think just that moment of discovery, it gives me the chill bumps every time. Like there's no better feeling in the world. It's sort of a euphoria. And so when you're on the verge of something like that it's not only exciting from a basic level, but when you know that it can actually impact people too, that it's ultimately going to change the way people are treated, that's like a whole nother level of satisfaction. Lung cancer, like many other cancer types, is not really just one disease. There are many different types of lung cancer, and it really matters what type of lung cancer you have because they all look and behave and respond to treatment very differently. Human tumors are largely driven by a family of genes called the MYC transcription factors, and they're either driven by c-MYC or l-MYC. And so that was really important because now what we want to do is when patients come in, we want to know, do you have a c-MYC driven small cell lung cancer or an l-MYC driven small cell lung cancer? And we found that that really matters because they each respond very differently to therapy. And we didn't realize that before because for 40 years we've been treating it as a single disease and everyone's been getting the same treatment. When I was in college, I had two family members around the same time be diagnosed with cancer. So my great-grandmother was diagnosed with lymphoma, my uncle was diagnosed with a brain tumor. And my uncle passed away really quickly, whereas my great-grandmother received chemo and actually survived and lived about 14 years after being diagnosed. And so it just hit me really personally that this is a big problem. It affects, so many people. It just seemed like you can't escape it. And so it was a problem that I was interested in. We always have our favorite hypothesis about what's going to happen, and we want certain results. We do, but we know that we're not supposed to do that. We need the data to just tell us what the truth is, and then we follow, the answer. And there is a tendency to be disappointed when you don't get what you hoped for. That's okay. It just means that our favorite answer wasn't the right one, but what it did tell us is going to lead us to something really exciting, because how it works is always the most exciting thing. We have multiple kinds of tomatoes, including the Cherokee purple tomatoes, some green bell peppers, zucchini squash, kale, beans. One of the major transitions from being a graduate student and a postdoc to being a faculty member is that you don't get to be in the lab and use your hands as much anymore. So, working in the garden for me is a chance to be outside, put my gloves on, use my hands, get dirty. And besides that, I really love tomatoes, and so I'm motivated to grow all of the things in the garden just because I love the fresh food, and it's so rewarding that, that I got to play a role in it. The best learning and thinking actually comes when you take these interspersed breaks. And so I think it's a rest for my brain that then when I come back to thinking about work, I feel like refreshed and invigorated and inspired. I think there are parallels in that, you're putting your effort into trying to make something like grow and develop and bear fruit, and it's always chaotic and it will also do whatever it wants to do, but it's beautiful in the end no matter what it does.